Math with AUB, we are about to embark upon the course of how to prove trigonometric identities that we use mostly direct or after cramming or memorizing. Let's see and find out how to prove them. Integral dx over root a square minus x square. If that is the case, look at this. First constant, middle symbol minus, then variable, no function derivative situation. No function derivative situation. We assume that x is equal to a sine theta. Some writers or literature say that you can also assume x is equal to a cos theta. It's up to you. Here sine is mentioned, that's why we have to take x is equal to a sine theta. The philosophy, the idea behind supposition is that we easily get rid of this radical sign. We easily get rid of this radical sign. That is the idea. Supposing this one, after supposition of this one, differentiate dx over d theta. Differentiation of sine is cos theta. Shift d theta there. Find the value of the differential dx. It is a cos theta d theta. It's R1, and we have supposed this. Just utilize these two suppositions in the original integral. We are going to get through. Dx means a cos theta d theta over a square. Instead of x, we write a sin theta. X having a square, we write a square sin square. Taking a square common, we have taking a square common, what remains? 1 minus sine square. 1 minus sine square. 1 minus sine square is equal to cos square. 1 minus sine square is equal to cos square. We have a square cos square d theta. A square cos square. These are perfect square quantities. A cos theta is the eventual answer in that case. We have a cos theta over a cos theta d theta cancelled out. 1 d theta. 1 d theta means theta plus c. Theta plus c. What we have assumed? Find the value of theta from here, because our original variable is x and we are traveling in theta. We put the value. We have supposed that x is equal to a sin theta. How to find theta? Solve for theta. It will become x over a sin theta. Taking sin inverse both sides, we have sin inverse x over a or sin inverse sin theta. They are neutral. Minus 1 plus 1 having 0 power 0 power equal 1. So theta is equal to sin inverse of x upon a. That's our eventual answer in that case. Sin inverse of x over a plus c. That's our answer in that case. If you suppose x is equal to a cos theta, there should be minus cos inverse of x over a. Let's move to identity number 2. X is dx over x square plus a square is equal to 1 over a tan inverse or tan x over a plus c. Let's see and find out how to get along with that. Dx over a square plus x square, it is equal to 1 over a tan inverse of x over a plus c. In that case, whether there is square root, variable first, constant first, there is no function derivative situation, it is very safe to assume that x is equal to a tan theta. Differentiation with respect to theta, dx over d theta. Differentiation of tan is sec square theta. Yes. Differentiation of tan is sec square theta. Solve for differential dx. Shift d theta over there, it will become a sec square theta d theta. That's our second supposition. That's one. Utilize both these values in the original integral. Instead of dx, I can write a sec square theta d theta. A square same. We have assumed that x is equal to a tan theta. There is square on x. There is, it can be written as a square tan square theta. A square common. A square common. We have a sec square theta d theta. A square is common. What left? Nothing left. 1 plus tan square. 1 plus tan square, it is equal to sec square theta. A sec square theta d theta over a square sec square theta. cancelled out. Here A remains 1 over A d theta. 1 over A d theta means 1 over A d theta. With respect to theta, its differentiation is only theta plus C. Find the value of theta from here. That is 1 over A tan inverse or tan of x over A plus C. That's our second proof. That's our second proof. Let's move to proof number 3. That's good one. Almost all the possibilities or permutation and combinations for supposition and partial fraction are present in that single frame. We have assumed x is equal to a sin theta, in that case tan, in that case sec, and in this case a partial fraction. Variety in a single frame. Yes. Question number 3, that is dx over x times root x square minus a square. It is equal to a 1 over a sec inverse of x over a plus c. Okay, cool. Look, there's a slight difference between supposition of sin and sec. Look at this. If that is the case, suppose x is equal to a sin theta. If variable first constant, then x is equal to a sec theta. Provided that you have confirmed that it is not for case of function and derivative, substitution case. X is equal to a sec theta. Differentiation of sec is sec as well as tan theta. Find the value of differential dx. Shift d theta over there. A times sec theta tan theta d theta. It's number 1, 2. Utilize both these values in original integral. We have dx. Dx means a sec theta tan theta d theta over x means a sec theta root x square means a square sec square minus a square. A sec cancel. We have tan theta d theta. Here a square common. We have sec square theta minus 1. Sec square minus 1 is equal to tan square. Tan theta d theta over a square tan square. A square tan square both are perfect quantities. They can be written as tan theta over a tan theta. Tan cancelled. 1 over is constant. D theta. Integration of d theta. 1 d theta is only theta. Theta plus c. We put the value of theta from here. In the same token, it is given by 1 over a sec inverse of x over a. Sec inverse of x over a plus c. Sec inverse of x over a plus c. That is also in that case. Look at this one. If there is root is present, it is case of sec. If there is no root, then middle symbol is negative. It is case of partial fraction. Partial fraction when it has linear factors, linear and different. Linear and different. Let's see how to handle this. We have dx over x square minus a square. There is no square root. Take x is equal to a sin theta. We can also prove with this. Let me give you idea from partial fraction. Take x square minus a square. It can be written as x plus a times x minus a. By resolving into partial fraction, we have a over x plus a plus b over x minus a is equal to 1 over x plus a times x minus a. Okay, we have assumed that we can split such type of function into this. Now we have to manage the value of capital A and B. Put here, take LCM, we will get this. Okay, cool. LCM, x plus a, x minus a, it will become a times x minus a plus b times x plus a is equal to 1 over x plus a, x minus a. Shift x plus a minus x on the right hand side in multiplication. We have a times x minus a plus b times x plus a is equal to 1 time x plus a, x minus a over, cancelled out, a times x minus a plus b times x plus a is equal to 1. Now we have to manage values of x to get values of capital A and capital B from these two brackets, from these two brackets, that is x plus a is equal to 0, we have x is equal to minus a, as well as from x minus a is equal to 0, x is equal to x is equal to, put x is equal to a, and then x is equal to minus a. Put x is equal to a, it will become a minus a plus b times a plus a is equal to 1. Cancelled out. We have b times 2a is equal to 1. So capital B is equal to 1 over 2a. 1 over 2a. Similarly, put x is equal to minus a. Put x is equal to minus a in same thing. X minus a times plus b times x plus a is equal to 1. Now put x is equal to minus a. Minus a plus b times negative a positive a is equal to 1. Cancelled out. We have a times minus 2a is equal to 1. So a is equal to minus 1 over 2. That's the value of capital A and capital B. Utilize here and integrate. We have dx over x plus a. Value of a is minus 1 over 2. Minus 1 over 2. Plus what is value of b? 1 over 2a dx over x minus a. Okay, cool. Now it's our function. Differentiation of x is 1 and having overall power 1, it is case of ln. Same thing is present here. X minus a overall power 1. Differentiation of x is 1. Function derivative. It will become minus 1 over 2a ln x plus a plus 1 over 2a ln x minus a. Knowing the fact that after taking 1 upon 2a common, let me settle this thing. Write first positive x minus a, then negative x plus a plus 1 over 2a common. We have ln x minus a ln x plus a. Now utilizing tiny property of log, they can be merged in a single log, writing minus log in division. X minus a over x plus a 1 upon 2a is there. That is the thing to be proved in that case. Look at this. A square minus x square, we have to suppose x is equal to a sin theta. In case of plus, whether square root is present or not, you can assume that x is equal to a tan theta. If that is the case, x square minus, they are slightly different. Look, constant first, then variable. In that case, variable first, then constant. We can assume x is equal to a sec theta. And in that case, there is no radical sign x square minus x square. We suppose it is case of partial fraction. Okay, it's my tiny effort for you guys. It's all by itself. Next.